I just want to talk a little bit about fractional powers because it's worth knowing what they are when it comes to talking about logarithms. We've already seen fractional powers a bit before when we have something like b to the power of 1 over p equals the pth root of b. Okay. Instead of using sort of a general base like b, let's talk about a base like 10. So 10 to the power of a half is the square root of 10, which is around about 3.16, something else. What about something else like 10 to the power of 2.5? What's that? Well, we can rewrite 2.5 as a fraction, 5 over 2, and then, if you remember, there's the rule b to the power of p, or raised to the power of q, is b to the power of p times q. We can say 5 over 2 is 5 times a half, so it's 10 to the power of 5. Then you take the square root of that. So 10 to the power of 2.5, you can work that out by doing 10 to the power of 5 and then taking the square root. Or alternatively, you can do it by taking the square root and then raising to the power of 5. It's exactly the same. Another fractional power, let's take 10 to the power of 3.75. That's the same as 10 to the power of 30 over 8, which can be written as the 10 to the power of an eighth to the power of 30. 10 to the power of an eighth is the eighth root of 10, and then you can just raise that to the power of 30 to get 10 to the power of 3.75. Another way of thinking about mixed fractions like 10 to the power of 3.75 is to use the addition rule. You can say that's 10 to the power of 3 times 10 to the power of 0.75, because 3.75 is 3 plus 0.75. That's 10 to the power of 3 times, I can write that as a fraction, 10 to the power of 0.75, that's 3/4, 10 to the power, and that equals 10 to the power of 3 times, now we use the power rule, 10 to the 1/4, that's the fourth root, to the power 3. So it's a different way of doing the same thing.